scatter plots and association. Our learning target for today is I can identify scatter plots that have positive, negative, or no association. First, looking at scatter plots. Scatter plots are graphs that use points to display numerical data with two variables, or bivariate data. So they're graphs that look to compare two different things. They help determine if one variable has an effect on the other, or if there are overall trends, patterns, or associations between the variables. So looking below, we have our first example. Susie went to the mall and surveyed shoppers to see how many items they had purchased and the total amount of money they spent at the mall. She created the scatter plot below. How many shoppers did Susie survey? So each point would represent one shopper. There are 16 points, so she surveyed 16 shoppers. And does the number of items purchased seem to have an effect on the amount of money a shopper spent? This would be yes, because if we notice, we are increasing our total amount of money that we spend per the amount of items. If I spend a low amount of money, I'm buying a low amount of items. Where if I'm spending a lot of money, then I'm buying a lot of items. So typically we would say if we spend more money, we are buying more things. Now looking at scatter plots and their associations, we have three different types of associations. The first being positive. So two variables have positive association when the variables move together. So for example, if one variable increases, the other variable increases. As one value goes up, the other goes up. The next association is negative. Two variables have negative association when the variables move in opposite directions. So if one value increases, the other value decreases. And the last association is no association. So two variables have no association when the change in one variable has no effect on the second variable. So the scatter plot is kind of everywhere. Looking at a couple of examples, we want to describe the association you'd expect to see between the following: the hours a person studies and the number of states they visited. Here we'd expect no association, because the hours a person studies would have no effect on the number of states they visit. B, the hours a person studies and their grade on an exam. This would be positive, because as the hours a person studies increases, we would expect their grade to increase as well. As one variable increases, the other variable increases, which is positive. And C, the hours a person studies and the hours they spend watching TV. This would be negative, because the more time you spend studying, the less time you could spend watching TV, and vice versa. So, as one variable increases, the other variable has to decrease, which would be negative. Now, looking at how we can describe scatter plots in more detail, if a straight line can be drawn to follow the overall trend of the scatter plot, we call it linear. If we can't draw a straight line, then it's nonlinear. If the points of data are close together, the association is strong, and if the points of data are widely spread, the association is weak. Now, looking at these examples, we want to label each type of association, the strength of the association, and whether or not it's linear. Looking at number one, from left to right, I'm increasing, therefore it's positive. Notice all the data points are close together, so it would be strong, and then I can draw a straight line through it, so it's linear. So we'd have positive, strong, and linear. Number two, left to right, I would have a positive relationship. The strength of the association would be weak because my data points are more widely spread apart, and I can draw a straight line through it, so it'd be linear. So it'd have positive, weak, and linear. Notice the differences between 1 and 2 for strong and weak. 1, they're very close together, where 2, they're more spread apart and there's less of them. That's the difference between strong and weak. Number 3, I'd have positive again because I'm increasing from left to right. The data points are close together, so I'd have a strong relationship. And then I can't draw a straight line through this. If I drew a line, it'd have to be curved. So this is nonlinear. So I'd have positive, strong, and nonlinear. Number 4, from left to right, I'm decreasing, so it's negative association. The data points are close together, so it's strong. And then I can draw a line through this, so it's linear. So negative, strong, and linear. Number 5, looking at it from left to right, I'm decreasing, so it's negative. The data points are more widely spread, so it's weak. And then if I were to draw a line through this, the line would have to be curved, so this is nonlinear. So I'd have negative, weak, and nonlinear. And then lastly, number 6, this is a no association because it's neither positive or negative. It's weak because all the data is spread apart. And then I can't draw a line through this, so it's nonlinear. Looking at number 7, we want to describe the type of association you'd expect to see between the following variables. Again, see it says expect to see here. We can understand that there may be outliers from time to time. Outliers are random, strange pieces of data that might not fit the overall trends of our entire data, but we want to think what's going to happen the majority of the time. So, looking at our first one, we have a person's height and a person's shoe size. This association is going to be positive because typically, if you're smaller in height, your shoe size will be smaller. Where if you're larger in height, your shoe size will be larger. Think about a baby. Babies have very small feet, whereas adults have larger feet. So as you grow, your shoe size grows. The number of letters in a person's name and a person's IQ. This is going to be none. The number of letters in your name has no effect on your IQ. You can be extremely intelligent and have very few letters in your name, or you can be very intelligent and have a ton of letters in your name. The number of letters in your name has no effect on your IQ. And the number of absences a student has and a student's GPA. This is going to be negative because, again, typically, if you are absent more, you are missing more instruction or more material that you are covering in class, and then your GPA is going to suffer because you are not getting that instruction. So, as one increases, the other decreases, which is a negative association. In today's lesson, we learned scatter plots are graphs that compare bivariate numerical data, and we can describe scatter plots as having positive, negative, or no association. They can be either strong or weak, and linear or nonlinear. That's a wrap on today's video. We'll see you in the next one.